there's two other kinds of events. There's independent and there's dependent. Okay? Independent events are events that it doesn't matter what happens, the next event, it will still have the same probabilities. For example, if I toss a coin and I get a heads the first time, if I toss a coin again, does it matter that I just got a heads? No, the probability is still the same, right? Okay, what if instead I am going to choose some drinks out of a cooler, okay? And there's some sodas and there's some juice and some waters, okay? Let's say I choose a juice, okay? And I go ahead and drink it. Well, then I'm going to choose something else. Does the probability of choosing something else change because I've already drunk the juice?
Yes.
No. That's
So if there's 50 drinks in the cooler at first, and I take one out and I drink it, does the number of drinks in the cooler change?
Yes.
So does the probability change?
Yes.
Yes. So choosing drinks out of a cooler are dependent upon each other because it does matter which one it is. Does that make sense?
Yes.
Okay. You can just sit on this one. What if I choose a drink out of the cooler and I see that it's a juice and I decide I don't want that juice, I really want a soda, and I put it back in the cooler and then I choose my soda. I didn't drink it at all because I didn't want it. I wanted a soda. So I put it back in and then I choose my soda again. Does that probability affect anything? No, it's not, because when I put it back in, my probability stays the same because it still has the same number of drinks. That first one was called without replacement, sorry. And the one I just said is called with replacement because I put it back in. With replacement means put it back in. Without replacement means take it out. Okay? So there's two events. A and B are independent. If the probability of A does not affect the probability that the other one occurs. Okay? The two events are dependent. If the probability of A occurs somehow changes the probability that B occurs. So, tossing one coin and then another, independent or dependent? Independent. For a presentation, a teacher chooses one student's name, then chooses another without replacing the first student's name. Dependent. If the number of people or drinks or whatever it is that's in a thing that you're going to look at changes, then it's dependent. A card is drawn from a deck of cards, put back, then a second card is selected. Independent because I put it back. Does that make sense? Okay, so let's look at the probabilities. So the next one says, it's telling me that if the events are independent, that I'm going to multiply the two probabilities together to find their probability. So on the first one, you toss a coin and then you roll a die. And we want to find the probability that the coin lands heads up and the number rolled is a 6. Okay? So what's the probability that when I toss a coin that I get a heads? A half. So I do 1/2. And then what's the probability that I get a 6 when I roll a die? 1/6. Okay, so you get 1/12, right? Okay. Next question. Suppose you toss a coin 4 times. What's the probability of getting tails 4 times? Well, what's the probability that you get tails the first time that you roll it?
1/2.
What's the probability you get tails the next time?
1/2.
And then? And then? So 1/2 times 1/2 times 1/2 times 1/2 equals 1/16. Okay, so you have this bag. There are 3 green markers. There are 3 blue markers and 2 yellow markers. You're choosing a marker and then replacing it. Or do not replace. What does it say? Don't replace it. Okay? And then you choose a second marker. So the probability that you have green and then yellow. What's the probability that you would choose a green marker the first time? 3 out of 8. Okay? So I chose my green marker. I'm setting my green marker to the side. What's the probability that I choose a yellow marker? 2 out of 7, because there's not the same number in there anymore. Okay? Probability that they're both yellow. What is the probability that the first one's yellow? 2 eighths. And then, okay, so I have that yellow one. It's now sitting to the side. What's the probability that I choose another yellow?
1/7.
It's not 2 anymore because I've chosen 1, so it's 1/7. Last one that we're going to do right now. Probability that there's green and then blue. So what's the probability that you get a green marker? 3/8. Okay, I'm setting the green one to the side. What's the probability that the next one's blue? 3, and then the bottom changes. So 9/56.